Radical equations are equations that contain variables in the radicand, like in this example, h equals 1.34, 1 and 34 hundredths times the square root of L. Those are called radical equations. Now to solve them, we first have to isolate the desired variable on one side of the equation and then square each side of the equation to eliminate your radical. The key concepts: if you square both sides of a true equation, the resulting equation is always going to be true. If a equals b, then a squared equals b squared. So if we have the square root of x equals 4, then the square root of x quantity squared is going to be equal to 4 squared. So we were saying anytime I have anything inside the radical sign, like if I have the square root of 10, and if I take that quantity squared, that is going to be equal to 10. If I have the square root of 428, and if I take that quantity squared, then I'll get 428. All right, let's take a look at that formula. It has to do with a sailboat. It says the water line length of a sailboat is the length of the line made by the water's edge when the boat is full. A sailboat's hull speed is the fastest speed that it can travel in. Now you can estimate the hull speed, h, by using this formula. H equals 1 and 34 hundredths times the square root of L, where L is the length of the sailboat's water line. So here's your problem. Idris and Sebastian are sailing in a friend's sailboat. They measure the hull speed at 9 nautical miles per hour. We're to find the length of the sailboat's water line and round to the nearest foot. Okay, so we have our formula. H equals 1 and 34 hundredths times the square root of L. Okay, what is 9 nautical miles per hour represent? All right, that represents H. So we have 9 equals 1 and 34 hundredths times the square root of L. Okay, what do I need to do now in order to get everything moved over except for what's under the radical sign? Just like when you do an equation and you're solving and you're trying to isolate that variable, what we're isolating that radical sign. Okay, I have to divide both sides by 1 and 3/4, or 34 hundredths. And what do you come up with? Good, 6 and 72 hundredths equals the square root of L. All right, now I'm trying to find out what the length of the sailboat's water line is, so I'm trying to find out what L is. How do I set this free? Okay, I have to square it. Now what I do to one side of my equation, I always do to the other. So you take 6 and 72 hundredths and square it, and you get approximately 45 and 16 hundredths will be equal to, or approximately, L. So it is about 45 feet. Any questions? All right, let's take a look at another problem. Now, it's a reminder, to solve a radical equation, you first must isolate the radical. In other words, it's kind of like with that absolute value problems that we solved. You've got to get everything to the other side except for the absolute value symbol. Well, the same thing with your radical. So in this case, if I had the square root of a plus 5 plus 7 equals 12, what do I need to do first? Okay, I'm going to subtract 7 from both sides. Good. And I get the square root of a plus 5 is equal to 5. Okay, what's the next step? Okay, I do have my radical isolated on one side, so now I can square both sides. So when I do that, what happens over here? Good, it just sets it free. It's a plus 5 equals, and what is 5 squared? 25. Okay, then I subtract 5, and I get a equals 20. Okay, now when you're finished, you do always want to double check and make sure that it can be used, because when we work with this radical sign, we can never have a negative number. So let's check and see if 20 works. 20 plus 5 is 25. Can I take the square root of 25? Yes. And is that going to make it true? Yes, it is. Okay, so our answer checks out. Okay, try the first one, the example. When you get finished, raise your hand, and I'll come around and check you, and then you can check your partner. All right, we will add 2 to both sides. And then I'm left with the square root of c minus 3 equals 6. Okay, now what I do? All right, square both sides, and I get c minus 3 equals 36. Add 3, and I get c is equal to 39. Okay, now what I need to make sure and do? Let's check it. 39 minus 3 is 36. The square root of 36 I can find. I subtract 2. 6 minus 2 is 4. So that works. All right, now your turn on 2b. Okay, in this case, I have to subtract 4 from both sides. I'm left with the square root of h plus 1 equals 10. Okay, then I need to square both sides. And I get h plus 1 equals 100. Now what I need to do? Good, subtract 1 from both sides, and I get h is equal to 99. And then I need to just do a quick check. 99 plus 1 is 100. I can find the square root of 100. Okay, so that's basically how you solve an equation in which involves a radical. Remember, the main thing you need to remember is that you need to get your radical sign all by itself first before you can then square both sides. Okay, we have one other type of problem we're going to take a look at, and that is what's called an extraneous solution. Now, when you square each side of an equation, sometimes you produce a solution that's not a solution of the original equation. And when this happens, these are called extraneous solutions. So we must check all solutions in the original equation. Let's take a look at this example. Okay, the radical is already isolated. So I just have to square both sides. Now, when you have more than one term on both sides, you need to use your FOIL and square the whole thing. So I'm left here with k plus 1 equals, okay, what's k minus 1 times k minus 1? If you don't remember the shortcut, then work it out using your FOIL. And I get k squared minus 2k plus 1. Okay, then I'm going to subtract k from both sides. And I'm going to subtract 1. Because I now recognize that I have a quadratic, so I have to set it equal to 0 in order to solve it. So now I have 0 equals still k squared minus 3k, and then these cancel out. Okay, now in order to solve this, we need to try to factor. Is there anything we can factor out here? We can factor out a k, then I have a k minus 3 left, and all that's equal to 0. Now, if you remember, when we have a quadratic like this, I know that either one of these terms then could be equal to, or excuse me, factors would be equal to 0. Either the k is equal to 0, or I know that k minus 3 is equal to 0. So if I have k minus 3 is equal to 0, if I add 3 to both sides, k would be equal to 3. Okay, so it could be either 0 or 3. Let's plug them both in. If I have a 0 plus 1, what do I get? 1. Okay, so I have the square root of 1 is 1. Now if I put a 0 in here, can I get a 0 minus 1 to equal 1? No, it doesn't. I can't say that a 1, because the square root of 1 is 1, is equal to a negative 1. Doesn't work. So we call this an extraneous solution. Let's see if 3 works. 3 plus 1 is the square root of 4 equals 3 minus 1, 2. Is the square root of 4 equal to 2? Yes, it is. So that is our solution. So just make sure that you always check to see that they work. And if they don't, that's called an extraneous solution. All right, let's try one example. We're going to solve this equation, and then we're going to check our solutions. Okay, I have to first square both sides since the radical sign is already isolated. And I get t plus 5 is equal to, and then I have t plus 3 quantity squared. So I have t squared plus 3t plus 3t plus 9, or t squared plus 6t plus 9. Okay, subtractor t, subtractor 5, and you get 0 equals t squared plus 5t plus 4. Okay, can I factor this? Well, let's try it. What would I multiply together to get 4, add together to get 5? T plus 4, t plus 1. I think that'll work. Okay, so we know that then t plus 4 could be equal to 0, or t plus 1 could be equal to 0. So t could be a negative 4, or t could be a negative 1. Let's check them. If I plug in a negative 4 here, a negative 4 plus 5 is the square root of 1. Is that equal to negative 4 plus 3 would be a negative 1. This is 1 equal to negative 1. Doesn't work, does it? Okay, let's try negative 1. Well, if I have a negative 1 plus 5, that gives me the square root of 4 equals a negative 1 plus 3. That is a 2. Is 2 equal to 2? Yes, it is. So that is our solution. Negative 1 is my solution. Okay, that concludes our lesson on solving radical equations today.